So today we're going to look into trapezium rule. So when we do the integration, so the main purpose of integration is to find the area under the graph. Let's say this is the graph. So I want to find this area. So what we do, we will use integration of the function. Let's say this is a function of fx, and here is a to b. So we will integrate a to b fx respect to dx. So now there will be a certain graph where we cannot use the integration, or the function is not be integrated. So what we are going to do here is we are going to find the area under the graph by using approximation. So the approximation method here we use trapezium rule. So what we are going to do here is, let's say there is a graph. So we want to find the area between this region. So what we are going to do here is we are going to break the area here into the trapeziums. So we just put the same interval length. Okay, so the interval between from here to here and here to here is always the same. It's always the same. It must be same interval. Okay, so then we join here as a trapezium. Yeah. So now what we're going to do is we're going to find the summation of the area here of the trapezium. So let it equal to A1, the first area. So my A1 is going to be, I name this as A. Sorry. So here will be the H0. So here will be the H1, the height of the trapezium. So for the area, the first trapezium area is going to be 1 over 2 multiply H0 plus H1 multiplied by A. The second trapezium area, so A2 is equal to 1 over 2 multiplied by, so here will be H2. So H1 plus H2 multiplied by A. Area of third trapezium is going to be 1 over 2 multiply H2 plus H3 multiplied by A. And the area of the fourth trapezium is going to be 1 over 2 multiply H3 plus H4 multiplied by A. So this will be the summation area of each trapezium which I draw here. So in order to find the area, it's going to be summation of area 1, summation of your area where n equal to 1 until n equal to 4. So it's going to be 1 over 2 H0 plus H1 A plus half A H1 plus H2 until it's going to be 1 over 2 H3 plus H4 A. So in general I am going to write as I can factorize this. Everything is going to be 1 over 2 multiplied by A, the width, plus multiplied by H0 plus H1. If you notice here, the H1 here and H1 here are repeated 2 times. So we are going to multiply with 2 multiply with H1 plus H2 plus H3. Sorry, here will be H4. Okay. So in general, I can rewrite this as 1 over 2 A as the width, H0 has the first height of the trapezium plus Hn, where the n here refers to the last height of the trapezium, multiplied by 2 H1 plus H2 plus until Hn minus 1. Okay, sorry, here will be plus. Okay, so this will be in general. Why I put Hn minus 1? So for example here, this is my H4. This will be my H4. So the Hn minus 1 will be H3. So it depends on the how many strips that we are going to use to calculate the area. Okay, let's look into example. Okay, now let's look into an example. So here I give you a curve with y equal to x minus 2 ln x, and find the area between from 0.5 to 3.5. So use trapezium rule with two intervals. So here I require two intervals to estimate the shaded region. So here we are going to draw the trapezium first. So for example, I just draw here. So since they want only two intervals, okay, so I draw a line here in between. Okay, so this is my first interval and second interval. There are two intervals. Okay, and then from here to here is 3. Okay, from 0.5 to 3.5 the interval is 3. So I divide into 2, is going to be 1.5. So here will be 0.5, and then here will be 1.5 plus 0.5 is 2, and here will be 3.5. Okay, so this is the first interval. So I'm going to draw the trapezium. So this is the first trapezium, my area 1 and my area 2. So first I need to find the height over here. Okay, we have 0.5, so we take 0.5 and substitute here. When x equal to 0.5, so my h naught is going to be 0.5 minus 2 ln 0.5, which is going to be 1.8863, and then when x equal to 2, so it's going to be my h1, which is going to be 2 minus 2 ln 2, equivalent to 0.6137, and then when x equal to 3.5, so your h2 is going to be 3.5 minus 2 ln 3.5, therefore it's going to be 0.9945. okay, and then so here this will be my h null, h1, and this is the last h, so it's going to be hn. So it's going to be 1 over 2 multiply our interval here, the size is 1.5 multiply, so it's going to be h null plus hn plus 2 h1. okay, so the first one and the second one will be here, plus the rest of the intervals will be here, the height. So 1 over 2 multiply 1.5 times my h null is going to be 1.8863 plus 0.9945 plus 2 times of this 0.6137. So my final answer is going to be 3.081. okay, so this will be the area of the trapezium. Okay, now when we do the estimation, it can be either overestimated or underestimated. Okay, it can either be over or underestimated. For example, for this case I need only this region, the area, but here you can see when I draw the line here, when I draw the line over here and then I draw the trapezium, so the area of trapezium is beyond the line, so this we call as overestimated. Then how does the underestimated graph look like? So normally the underestimated graph will look like curve inwards. So for example here, so I want to draw here, so for example here, the area of trapezium is smaller compared to the actual area that we need to find. So this we call as underestimated of the area. And if we do more intervals of the trapezium, for example here I only do 2 intervals. If I do more intervals, then we will get more accurate area compared to that we use a less straps. Okay, so this will be the finding area under the graph by using trapezium rule. Thank you.